Welcome to Aura Digital. So in our previous session, we discussed about big data Hadoop 1x architecture. In Hadoop 1x architecture, we completed half of the architecture in previous session. Now we'll discuss about the remaining architecture. Here in earlier session, we discussed completely about the name node, how user will send request, and how job tracker processing data, and also how task tracker will write the data into blocks. Okay, now how task tracker will give status updates to job tracker. Okay, because job tracker assigned one task to task tracker, so that task tracker executed and it is stored data inside b1 block. Okay, but after storing data into b1 block, task tracker has to give updates back to job tracker, right? So how it will give updates back to job tracker? Okay, so here we have one concept, okay, that is progress report. Okay, progress report. Okay, so how task tracker will send a progress report to a job tracker? Okay, so here task tracker to job tracker. Okay, so basically in a Hadoop 1x architecture we have heartbeat signal concept. Okay, so generally every 3 seconds, each and every task tracker will send heartbeat signals to job tracker. By default, every 3 seconds, task tracker parallelly all the task trackers, each and every task tracker will send heartbeat signals to the job tracker. So what is the use of this heartbeat signals? Okay, so first point every 3 seconds, but second point, what is the use? Okay, so use means if task tracker is sending heartbeat signals to job tracker, that means this particular job tracker will assume that this task tracker is alive. Okay, if it is continuously sending status to job tracker means then job tracker will consider task tracker is alive or not. Okay, if it is continuously sending, then job tracker will assume okay, this is alive, this task tracker is working with a good health condition and it is alive. Now for example, this task tracker 3 seconds happen, so heartbeat signal not sent to job tracker, you can assume, and again after 3 seconds also it is not sent. Then how job tracker will consider this task tracker is not alive or not with a good health condition? So job tracker will wait till 10 attempts. 10 attempts means each attempt 3 seconds, right? So till 30 seconds, job tracker will wait. Even 30th second or 10th attempt also, task tracker not sending any heartbeat signal to job tracker means then this job tracker will consider this particular task tracker is crashed or not with a good health condition. Okay, then further tasks it will assign to different task trackers. So job tracker is assuming this task tracker is dead or crashed, so whatever further tasks will be available, those tasks it will assign to other task trackers because this task tracker is not working, first task tracker is not working. Okay, so this is about your second point. Okay, and third point, progress report. Okay, progress report. Okay, so job tracker assign one task to task tracker. So task tracker has to execute that job and it has to store data inside block, right? So once that task is executed, then task tracker will send a status to job tracker via same heartbeat signals. Every 10th attempt, every 10th attempt, it will send a progress report to job tracker. That means every 30th second, it will send a progress report to job tracker. Okay, so and so task is successful. If successful means successful information, it will send to job tracker, or still it is in progress means in progress status, like 30% completed, 30% in progress, or 40% in progress, or 70% in progress. So that information via heartbeat signal only every 30th second, it will send to job tracker. Even if it is failed also, failure information, if it is failed also, failure information, this particular task tracker will send to a job tracker. So this is the use of heartbeat signals. Okay, so make sure that these 3 points very important. Okay, only these 3 points, due to these 3 points only, job tracker will come to know task tracker, work related, progress, or task status. Okay, so first point, every 3 seconds heartbeat signals it has to send to job tracker. If it is continuously sending means, then job tracker will consider that okay, this particular task tracker is alive. If it is not sending means, it will wait till 10 attempts. Even 10th attempt also, if task tracker didn't send any heartbeat signal means, then job tracker will consider task tracker is dead or crashed. And the third point, every 10th attempt, task tracker has to send a progress report to task job tracker. Okay, progress report to job tracker. Okay, so now job tracker got a response back from each and every task tracker, and then same job tracker will give update to user. Okay, whatever task you requested, that is executed successfully. But now my doubt is, here we have 3 data nodes. Data node 1 3 blocks, but one block is full. Data node 3 we have 3 blocks, but third block is full. So how name node will come to know these 2 blocks is full? Because name node should have that particular information, or else if different user will request again name node, right? I have one data file, I want to store my data, could you please assign some blocks? But name node should know, right, what are the blocks is already full and what other blocks or space is available. That information up to date name node should have that information. So now how name node will come to know this particular block is full or not? Okay, so here also each and every data node, it will send heartbeat signals to name node. Each and every data node will send heartbeat signals to the name node. So what is the purpose? What is the purpose? Okay. So now again a heartbeat signals concept only, but a heartbeat signals between data nodes to name node. Earlier task tracker to job tracker, but now heartbeat signals concept between data nodes to name node. Okay. So here also every 3 seconds, this is by default 3 seconds. Okay, by default 3 seconds, every 3 seconds each and every data node will send a heartbeat signals to name node. That means name node will consider okay, this particular data node is alive. If it is sending continuously heartbeat signals to name node means, then name node is considering that particular data node is alive. Okay, in case if this data node is not sending heartbeat signals to name node, then it will wait 10 attempts. Even if 10th attempt also data node didn't send any heartbeat signals to name node means, then this name node will consider this particular data node is crashed or not with a good health condition. then what name node will do? Then further user requests, the name node will consider to assign blocks to only data node 2 and data node 3 because this data node is not responding. This is crashed or maybe not with good health condition. Okay, and now here it will send block level report also. Block level report means data node has to give updates to name node. What other blocks, how many blocks are there, what other blocks is full, what other blocks or space is available. So while sending heartbeat signals to name node every 10th attempt, each and every data node will send a block level report to name node. Okay, so I have three blocks. B1 block is full and B2, B3 block space is available. So this information data node will send to name node. Then name node will update inside metadata. So data node 1 only two blocks available. That information it will capture. Even B1 block also full. That also it will capture. Okay. Whenever some other user will request, then name node will consider only B2 and B3 blocks because only B2 and B3 space is available. And same time this data node also parallelly it will send heartbeat signals to name node. So here also B3 block full means 36 MB. Okay, and the remaining space it is not possible to use for other data file because remaining space completely it will be waste. So this data node also it will give update only B1 and B2 block space is available. So all this block level information each and every data node via heartbeat signals, it will give updates to name node so that the name node will update metadata. Okay, so this is how name node and job tracker getting updates from data node and the task tracker. Okay, now I have one doubt. So this particular data node you can assume crashed or not responding, but here user trying to read the data. Maybe user executed one query, read query, select star from employee or select star from customer. Then how it will read the data? How it will read? Because this particular data node itself crashed, that machine itself not working. Then what is the backup? Okay, so coming to backup now, generally in big data Hadoop, each and every piece of data it will replicate in three places. Okay, now we'll discuss about the replication factor. Okay, so replication factor by default your data in big data Hadoop, three different places it will replicate. How many places? Three different places. One piece of data, three different places it will replicate. That means you can assume same data, maybe same data, it will be replicate in maybe another block. Okay, so same data now you can assume here also available 64 MB, and same data it will replicate here also. So that means here also 64 MB available. Okay, so now you have backup, right? If first data node 1 goes down, name node have information that same copy of data it will be available in data node 2 and data node 3. So from here it will read another copy of data and it will show to user. So this is what about the replication factor. If one copy not available, other replication copies related data available in Hadoop cluster. From there, it will read your data. So even now, data node 1 is crashed. Maybe third also crashed, but still data node 2, inside data node 2, one more copy available. Okay, so by default, replication factor, by default, 3 copies of data it will store, but you can increase replication factor, you can increase or you can decrease also. Okay, you can decrease also. So if your data file size is 100 MB with replication, how much space is required? 300 MB, because replication factor 3 means 300 MB. Okay, if it is 10 terabytes means 30 terabytes of space is available. So replication factor by default 3, but you can increase or you can decrease. Okay, if you want, you can make it only 2 replication factor. That means only 2 copies it will store. Or if you want 10 copies, each piece of data, if you want 10 copies, you can specify that also. That is basically configuration where they will do this replication factor configuration. Means in backend we have one data file hdfs-site.xml file. Inside that XML file, basically Hadoop admin team, they will do configuration like heartbeat signals configuration, and the same time they will do a replication factor configuration also. Okay. See, by default here every 3 seconds, and here also by default of 3. In case if they don't want 3 means, they will in configuration file they will make it a 5, or maybe they will change it to 2. Okay, here also instead of every 3 seconds they can make 10 seconds, or maybe they can make 2 seconds. It is based on maybe a traffic or maybe a project or requirement that is configurable. If you don't want to configure, by default it will consider only 3 seconds, and replication factor 3 copies. Okay, so this is about backup or replication factor. Now you can assume all these nodes are there in only one location and one server. So if you keep your data center in only one location and one server, if that particular server or location maybe something happened, means your entire cluster will be down. At that time data backup not available, and even you are unable to access. So that's why in real time generally what they will do, they will maintain multiple servers or multiple clusters, like maybe in India one location, okay, maybe Bangalore one data center they will maintain, or maybe some different location US you can assume another data center. Okay, so whenever name node will assign blocks to user, what it will do, nearest data center 2 copies. Okay, nearest data center 2 copies it will assign 2 replication factor, but the longest distance server, maybe in a US server, it will assign a third replication factor related block. That means you can assume data node 1, data node 2, you can assume that only these two nodes in India server, these two missions. But the third mission or third data node, it is available in USA. So if India server is completely down also, data available backup in USA server. So from there it will read. Whenever user trying to read the data, then it will read from USA server and it will show. That's why most of the multinational companies, they will maintain data centers in different locations, because If one location, if one server goes down or crashed also, data backup will be available from other location. Okay, so same way, even here, this 36 MB size also it will replicate in uh, different nodes. So to replicate also here, okay, basically 36 MB, okay, 36 MB. So same, this also third replication, okay, third replication required, okay. So here third replication, here also 36 MB, okay. So whenever name node will give response back to user for space allocation, name node will assign blocks with replication. Okay, initially we discussed like here only two blocks, right? So basically if I tell about a replication starting itself, you people will confuse. That's why generally if your data file size is 100 MB means how many blocks required? 64 MB one block, 36 MB two blocks. That means total two blocks with replication. With replication, how many is required? 2 into 3 replication factor. Total 6 blocks it will assign. Your name node with the replication factor, 6 blocks it will allocate. So user can contact job tracker. These are the 6 blocks for me assigned. So that job tracker will help to store the data, same data in 6 different blocks. So this is about replication factor. Okay. So if one data node goes down, we have backup another data node, or maybe from different location server or different data center it will read. But my doubt is if a job tracker system or node goes down, what is the backup? Okay. So then there is no backup. Okay. So here 1x disadvantages are drawbacks. Drawbacks. Okay. Drawbacks. So first point, space wastage. This already we discussed, right? Out of 64 MB block storage space, if you store only 36 MB, remaining space will be waste. And the second point, if job tracker goes down, again we have to wait till job tracker is up. There is no alternative. No one will do job tracker work here. Single job tracker, only job tracker having processing capabilities to read your data or to store your data. Compulsory, each and every user compulsory has to contact only job tracker. So there is no backup for job tracker. If job tracker goes down means we have to wait till it is up. We don't know when Hadoop admin team will make it up. Maybe if this particular job tracker, if some power suppliers some repair means they will do immediately within half an hour or one hour. Maybe they need completely, maybe that particular machine or node is crashed means again they have to replace, right? So they have to buy that particular node or system or hard disk. It will take time, right? So we don't know within half an hour or 2 or 3 days. So that till it is up we have to wait. That is one major drawback in Hadoop 1x architecture. Okay, now if name node goes down, what is the backup? Without name node it is not possible to contact data nodes, or even for retrieval also it is not possible. Data retrieval also not possible and data storage also not possible, because to read your data or to store your data, user or job tracker compulsory has to contact name node only, because name node has to give information. Your data stored in so and so data center and so inside so and so data node and so block. So that information only name node is having, because name node is the boss for entire Hadoop architecture. So now this name node goes down means there is no alternative or backup. Okay, now we'll discuss about that. Okay, if name node goes down, here I have one FS image. Here I have one FS image, and you can assume here I have one more node, that is secondary name node. Okay, now I will explain about FS image and secondary name node. What is the purpose of FS image and secondary name node? First we'll discuss about FS image. Okay, this FS image, what it will do generally, each and every data node will send progress block level report to name node, right? Every 30th second. Okay, that means every 30th second name node is updating metadata, always latest metadata. Okay, so whatever metadata, latest metadata, generally it will come, it will be same, it will be available in FS image also for backup purpose. Okay, so it will keep that every 30 minutes till 30th minutes FS image will keep metadata backup, and it will send to secondary name node. So that means FS image always latest metadata, it will keep till 30th minutes. After that it will move to secondary name node. Again, next 30 minutes, whatever latest uh, block level report or metadata, it will update in name node. Again, it will keep next 30 minutes, it will keep latest metadata in FS image. Again, it will send to secondary name node. So secondary name node is backup for name node, only metadata backup. Okay, just please note down this point. Okay, only metadata backup. That means if your name node goes down means your say secondary name node will not work like name node. That capabilities secondary name node doesn't have. Only metadata will be available backup in secondary name node. But secondary name node will not act like name node. So if name node goes down means we have to wait till it is up. Then what is the use of secondary name node? Why secondary name node is required here? That means in case if this name node completely crashed, Hadoop admin team, you can assume they replaced with the new mission or new node. Generally what they will do, first they have to install Linux operating system. On top of that they have to install HDFS Hadoop softwares. Once a system is ready, then entire metadata they will copy from secondary name node to new name node. Then they will make new name node up. So once name node is up, then entire old metadata like which user related data is there in which data node or which block or which data center, that information again new name node having, right? Because secondary name node having always latest metadata and old metadata also, that entire metadata Hadoop admin team they will copy into new name node, then new name node will work like your old name node. Only that is the purpose secondary name node available. But till name node, new name node is ready, everyone has to wait. So this also one major drawback in Hadoop 1x architecture. Okay, so this is about Hadoop 1x architecture. Okay, and next session we'll discuss about Hadoop 2x architecture. So 1x architecture, what are the drawbacks we have noted here? Those drawbacks Hadoop 2x resolved or not. So those things we'll discuss in next session. Okay. So before going to Hadoop 2x architecture, here generally task tracker will execute and here your data it will write, right? Whatever content is there inside data file, that content who will write inside block. Okay, inside block who will write your data. So here we have two classes. One is a data streamer Java class, another one pipeline Java class. These two built-in Java classes, it will come with the Hadoop framework. Okay, so data streamer Java class, what it will do, whenever task or tracker will start executing this data streamer Java class, it will write content inside the B1 block. Your data file contains some data, right? That data who will write inside block means data streamer Java class. Okay, but what is the purpose of pipeline Java class? Your only first copy data, first replication copy data, only your data streamer Java class will write, and the second replication and the third replication copies of data your pipeline streamer class will take care. Pipeline Java class will write second copy and third copy replication copies related data who will write means pipeline Java class, because all the three copies only data streamer has to write means it will take time, right? That's why only data streamer class first copy of the data it will write, remaining second and third copies of data pipeline Java class will take care. So internally other data nodes will interact each data node. So for example, first copy this 64 MB. So this data node 2, it will connect with the data node 1 B1 block and it will copy the data into B3 block. So second replication copy. Same way third replication copy. This is how about 1x architecture. Okay. So next session we'll discuss about Hadoop 2x architecture. Thanks for watching this video. Bye bye.